All right, today we're going to be taking a look at solving inequalities, polynomial inequalities, and rational inequalities in one variable. So we're going to start with a polynomial function here, f of x equals, and then we have a couple of different factors there. Our zeros from those factors would be 2, -3, and 5. And the factor of, or the 0 of 2 would have a multiplicity of 2 because of the square on its binomial. So those are the three zeros that we see in this graph here. We're going to use this graph to help answer the questions about where this function is positive, negative, or 0. So to solve for where f of x is greater than 0, we are looking for the intervals of x which make the function positive. So first we're going to think about where the function is positive. The function is positive anywhere above the x-axis. This is where f of x is positive, or greater than 0. So we can see that the function is actually positive here and here. But the x intervals that make that possible are the intervals here that will represent an interval notation in a second. Where we want f of x to be less than 0, when we're solving for x there, we're looking for when is the function below the x-axis? When is the function negative? So that would be obviously dealing with this part of the graph here, but not at that 2 because it's equal to 0 at that 2 right there. So I'm just going to put a little note here too that on the x-axis is where f of x equals 0. So those are the major three things that we're going to look for. Where is it positive? Where is it equal to 0? Where is it negative? So we can answer any of these four questions that we see in number 1 here. It says use a graph above to answer these following inequalities. We're going to give all of our answers in interval notation. We should be used to that by now. All right, so where is this thing greater than 0? Well, it's greater than 0 for x values from -infinity up until -3, and then again from 5 to positive infinity. That is where the function is positive. It's positive and equal to 0 in those same intervals, but now I can include the -3 and the -5, excuse me, the positive 5. And there's also another spot where it is equal to 0 because of that line there, that or equal to 0. We can now also include that value of 2 as well because it equals 0 there. So we're going to put that 2, since it's a single value, inside those curly brackets. That's where we would list single values in interval notation. So those are where it can be greater than or equal to 0. All right, less than 0, now we're looking below the x-axis. So just less than 0, not equal to, would be from -3 until that value of 2, but we can't include 2 because it equals 0 at 2. And then we would go all the way to that 5. Now for the last one, where is it less than or equal to 0? That would be really anywhere on this function from -3 until 5. That whole time, it fits that description. It is less than or equal to 0. So we can include that -3 and the 5. We don't need to break that thing apart at the 2 like we did here, because the continuous interval would be a solution to that question. The next thing we're going to take a look at is a sign chart. Now, essentially, a sign chart will do the exact same thing that the graph did. Okay, so we can answer these questions with either a sign chart or a graph. I want you to get used to using both of them. All right, now here's what a sign chart looks like. A sign chart will have a number line. This will look a little bit nicer. It'll be a number line with the zeros from the function on it. So this function that we have here has zeros of 1, 7, and -5/3. Those are the three zeros. I'm going to put those on our number line here. Here's -5/3. Now, these have to be in order, but they don't have to be necessarily scaled correctly. There's 1 and there's 7. Okay, so now what we want to talk about is what happens at those values before those values and after those values. So what I like to do here is put the factors that these came from over to the right over here. So I'm going to go in the same order from bottom up here. The negative 5/3 came from the factor 3x plus 5. The 1 came from the factor x minus 1, but that has a multiplicity of 2. And then the negative 5/3 came, oh, I'm sorry, the 7, the largest one that we have, came from the factor of x minus 7. Okay, and then what I do is I put a light line at each of those spots right there. I'm trying to break the graph into pieces at each of those zeros. At each of those values, the function becomes positive. Excuse me, becomes 0. At each of those values, the function is 0. Okay, so what I'm writing up above here is what f of x is at those different values. So at negative 5/3, the function is 0. Why? Because if we put negative 5/3 in just to this guy, it makes that thing 0, which would make the entire function 0. Let's focus on that negative 5/3 yet, and we'll focus on this factor. If I put in anything less than negative 5/3, this factor itself would be negative. We're going to represent that with a dashed line. So anything that I put in less than negative 5/3 is going to be negative. Anything bigger than negative 5/3 is going to make that factor positive. So I'm going to put a solid line then representing that would be positive for any value that's bigger than negative 5/3. Let's go up to the 7 now. Anything that I put in that is less than 7 will make this function negative. Or actually, it'll just make that factor negative. Anything that I put in that is bigger than 7 would make that guy positive. So here's a little key for our sign chart. I'll call this our sign chart key. And I'm only doing this for this example, even though we always use this idea. You don't have to write this for every function. So this means positive. This means that that factor is negative. The last one that we have is this x minus 1 squared. Well, if you think about it, since we're squaring this thing, it's always positive. Whatever comes out of it, doesn't matter what you put in for x, this factor is always going to be positive because you're squaring it. So this guy here is always going to be positive. Now, the last thing that we want to look at here is the product of these factors. We want to look at the product of these factors. So we want to look at what is the entire function. So in this case right here, what we are doing is saying 2 of the factors are going to be negative and 1 factor is going to be positive. Well, if we multiply those all together, that means that the entire function itself is going to be positive. So I'm going to put a big plus sign here to say that the function is positive. Here we have a negative, a positive, and a positive. Well, if I multiply those 3 things together, I'm going to get a negative. A negative times a positive again, that's negative. And then the last one, 3 positives being multiplied together is a positive. Now, if we look back up to our graph, we should see the exact same thing that we have written here. Okay? Up until negative 5/3, it's positive. Then it's 0. Then between negative 5/3 and 1, it is negative. Between 1 and 7, it is also negative. And then after 7, it's positive. So this thing says the exact same thing that our graph did. It's just a different way of representing it. So we would use this in place of a graph. So now we can answer this question right here. Where is this thing greater than 0? Well, we've actually already answered this up above, but let's use our sign chart here. Where is it greater than 0? Where is this thing greater than 0? Where is it positive? Well, it looks like for values up to negative 5/3, so from negative infinity until negative 5/3, and then from 7 to positive infinity. If I would have thrown this or equal to there, okay, then we would have included these values here as well. Okay, but it didn't have that, so we're not going to include that. So that is a pretty straightforward sign chart. You're probably asking, why would we ever use a sign chart if we can graph it pretty quickly like this? I mean, when we're giving it in factor notation to graph this like this, it goes pretty quick. To answer you honestly, I don't know. If I had the choice, I'd probably go with the graph. But here's what I want you to use sign charts. I think it's a much faster way of answering rational inequalities. So we're going to go to the back side here and look at a rational inequality. We have negative 1/3, 1, and negative 3 as our zeros, okay, of our three different factors here. So as I'm making my sign chart, I'm going to make a number line. I'm going to put those values down in order. So I've got negative 3, and then negative 1/3, and then 1. And I'm going to put those factors going up the side here. So x plus 3 gave me the negative 3. 3x plus 1 gave me the negative 1/3. And the x minus 1 gave me the 1. And we'll talk about what happens at each of these points first. What happens at negative 3? What happens at negative 1/3? What happens at 1? Well, the first one, the top one is easy. Sorry, the top one, the red one is easy. At negative 1/3, we would get 0. Okay? Because the numerator would be 0, which would make the whole function 0. We can't just put zeros on the other ones, though, because if we put in negative 3 or 1, we know that those are vertical asymptotes. The function is actually undefined at those spots. So what I'm going to put there to represent that is I'm going to put like the no solution symbol. You could, if you want to, you could put VA for vertical asymptote. You could put U or UND for undefined. That's not bad. In fact, I'm going to use that one for this. Sometimes I just use that no solution thing too, but really what it is it's undefined. Here is what g of x is. G of x is undefined at negative 3, 0 at negative 1/3, and undefined at 1. Now we're going to put our positive and negative lines in there. I know that x plus 3 is going to be negative before negative 3 and positive after. Negative before it's 0 and positive after. Negative before it's 0 and positive after. I don't have anything being squared here, so I don't have a solid line going all the way across like I did in the last one. So when you get used to it, that's a pretty quick thing to make, that sign chart right there. That went pretty quick. That was a lot faster than actually graphing it. And now we can answer all 4 of the questions down here. Okay, let's first put what we know from the function if we multiply the factors together. So we know that in the, I'm just going to clean this up a little bit here. We know that in the first area here there, we have 3 negatives being multiplied together, so that would make that thing negative. 2 negatives and a positive, 2 positives and 1 negative, and 3 positives. So that's what that function looks like. If we graphed it, we would see the exact same thing happening. In fact, the sign chart could be useful in graphing as well. All right, so let's answer these questions that we have down here. Where is this thing less than 0? Well, less than 0 means negative, so we're looking there and there. It's not equal to 0, so I only want those values. So we want to go from negative infinity up until, let's see, negative 3. Union. Remember, negative 3 is actually a vertical asymptote. And then from negative 1/3 to 1. I didn't want to include any of those values because it's just less than 0, not less than or equal to. The next one is looking for where it is positive. I'm looking at C actually right now. I'm going to do that one next. So where is this thing positive? Well, right there and right there is where this is positive. So that would be between negative 3 and negative 1/3. And then also from 1 to positive infinity, everything after 1. Those are the x values, okay? That's what these guys represent down here in case that wasn't clear. These are all the x values down there. All right, so now we're going to look at B and D. Now, B is asking where is it less than or equal to 0. So that would be there, there, and there. Notice how we cannot include that negative 3 value because it's a vertical asymptote. X cannot equal negative 3. So we want then our interval to be from negative infinity up until negative 3. Then from negative 1/3, including that negative 1/3, because it can equal that, it's up in the numerator, all the way up until 1. Okay, but it can't equal to 1 because those are vertical asymptotes. So these guys here, we got to be careful. Those are vertical asymptotes. So you can't have brackets where vertical asymptotes are, since x can't equal those. In D, where is it greater than or equal to 0? I just want to see my sign chart yet. We are then looking at there, and then also that 0 right there. So from -3 up until -1/3, and we can include that because it's a 0 up in the numerator. And then from, let's see, 1, but not including 1, up until positive infinity is also where it's positive. All right, our last problem here has to deal with combining in order to have one inequality. Okay, you must have a single fraction in order to answer these questions. So what we're going to do is try to get a common denominator here, which I would just multiply the two denominators together. So what I'm going to do is multiply these fractions by, I can't talk and write at the same time, by the other denominator over itself. Okay, so that would give me a common denominator of that x minus 3 times x. Oh, let's back up here. I can't talk and write at the same time today. So we want to multiply by the other denominator because we want the LCD to actually be made up of those two denominators, x minus 3 and then x plus 3. Good Lord. And then x minus 1. There we go. Okay, so we know that when I multiply the denominators together, they're both going to become the same thing. They're both going to become that LCD that we want it to be, which is x plus 3, x minus 1. Finally got it right there. But now we need to multiply our numerators together. So distributing 1, that looks pretty simple. Careful here, distributing the 2, especially if this was minus, you'd want to distribute that negative with it. But it's not, so we don't have to. So we got 2x minus 2 here. Now we'll combine everything in top. Make sure we keep our less than or equal to 0 there. When we combine everything in top, we have 3x, and then 3 and negative 2 is positive 1, and we're looking for this to be less than or equal to 0. And then what I hope you notice is, this looks familiar, it's actually the same exact function that we were dealing with up on top. We just wanted some practice in watching your teacher mess up finding an LCD there for a little bit and then combining two fractions together. So we got some good practice there. But really essentially what we're answering here is the same as, I believe it's question B above. Our answer would be the same as question B up above because it had that same function and it was asking where it was less than or equal to 0. So our answer for that last problem would also be that same interval right there.